Hi everyone, and welcome to this video in which we will be looking in detail at abstract classes. This video has been made as a prerequisite to accompany the series of videos on multiple inheritance and polymorphism. This video is for people with good understanding of what a normal concrete class is and what a method is, as well as those familiar with single class inheritance. Although we will have a quick recap of these concepts before we get onto the main topic for today, if you are completely unfamiliar with any of these ideas, I suggest doing a bit more research before you continue watching. So let's remind ourselves, what is a class and what is an object? In a computer program, a class can be thought of as a template for creating objects of the same kind, and methods can be thought of as behaviors that these objects can perform. For example, in the real world, there are various different entities such as human beings, animals, cars, and so on. We can think of these entities as classes. They're general terms for describing a group of things that fall into the same category. These things we will refer to as objects. For example, male and females are different, but are actually just two variations of a human, or a sedan and a minivan, which are just variations of cars. These general categories are what we call classes, and the more specific versions of these categories are what we call objects. Methods then, as I said, can be thought of as behaviors that these objects can perform. So for example, a human might be able to sleep, or eat, or go to work, and a car might be able to drive or park. It's inside these methods that we put our code to tell the objects how to perform these behaviors. Now we can go on to look at abstract classes. Simply put, an abstract class is a class that contains at least one abstract method. An abstract method is a method that has been declared but not been defined, which means that it has no method body. We might want to create an abstract class if, for example, we had a number of classes that we wanted to offer similar behaviors. Inheriting from abstract classes would allow us to implement these methods however we like by defining them differently in each child class. It allows us to define some default behaviors that we want our child classes to have, but gives us the flexibility of deciding how each subclass performs it. In a case where we want some classes to do similar things, this is particularly useful. For example, imagine we wanted to create an online system for members of a school or university to use to do various things like check their grades or receive their homework. One class we might have might be a student class, which would detail things that students can do on the system. But now, let's say we wanted to display a different welcome message depending on what kind of student was using the system, such as a postgraduate or an undergraduate. What we could do is create two separate student classes and define the methods in each class. But this would mean that we would need to decide exactly how we want to implement these methods at the time we write them, which we might not necessarily know, perhaps because there are some other things that need to be implemented before we can decide. So instead, we can use abstract classes, which will allow us to bypass this by using abstract methods which don't need to be implemented when you write them. So let's create an abstract class that will store our welcome method until we're ready to implement it later. Let's call this class student because it's going to be the students that will see the message. To declare a class as an abstract class, we would need to add the keyword abstract to the class's name, like so. And within the abstract class, we would write our abstract methods with no body, but instead with parentheses and a semicolon at the end. The body of our method has not been defined here because it will be defined in whichever class inherits from this class. To demonstrate this properly, let's build up our classes in our development environment so that we can actually run our code. So here we have a student abstract class that also contains an abstract welcome message method. We can then go on to make classes that are going to represent the students that will be using the system, such as postgraduates and undergraduates. As normal, we use the extend keywords to indicate inheritance from one class to another. But now, unlike inheritance, where the method is already defined and ready to go, we could fill in the details for the welcome message method how we want for this particular class. So, this is an undergraduate class, so let's say welcome undergraduate. And then we can go over to our other class for postgraduates and do the same thing. Add extend student, and then we can define the method body as welcome postgraduate. As we can see, we had an original welcome message abstract method that was not defined, and then any class that wanted to use that method can define it however it likes. Now, when we want to use the method on our undergraduate and postgraduate student objects, we can specify which one of our messages should show when that object is in use. We do this by creating a new object with the keyword new, and then using the object's name followed by a full stop and the method call which we would like to use, which is called welcome message. So here we've created two new objects, PG and UG. Because they share an abstract class, they're actually both able to be created as variables of type student, their superclass, but still make use of the specified objects of type postgraduate and undergraduate, respectively. This is possible through polymorphism, which allows us to demonstrate that these two classes have a common superclass that they share. You can check out the video on polymorphism for a more detailed explanation of how this works. When we invoke our welcome method on each of these two different objects, we should get the relevant welcome message printed out. Let's run that and see what happens. So as we can see, we have two different messages show up for the two different objects. A key thing to note is that within an abstract class, not all the methods must be abstract. I mentioned before that abstract classes allowed us flexibility to change methods as we wish, but another advantage is that they also allow us to group similar classes together. Knowing this, we're able to say that the subclasses who extend these abstract classes must be related, as they all have to implement, at the very least, the same method specified in their abstract superclass. This can be really helpful for someone who's not familiar with your code, for example, as it will help them spot classes that are related. Hopefully this has given you a clearer idea about abstract classes